Hi everyone, first of all I would like to thank you for visiting our poster presentation. My name is Aykut İşleyen and I will present your research Tactile Roughness Perception of Visual Gratings by Electrovibration, and then Dr. Yasin Vardar will be answering your questions. So let's get started. Touchscreens are an important aspect of our daily life. However, our interaction with current touchscreens involve auditory and visual channels and lack tactile feedback. In that sense, surface haptics aims to enable tactile channel on touchscreens. For example, in future, we will be able to feel the simulated texture of jeans before purchasing them online. In this regard, in our study, we aim to investigate texture perception of real and virtual textures. We believe that studies in this area will pave the way to more realistic virtual textures. Currently, the most promising method in surface haptics is the electrostatic actuation. This is also the method we chose to generate the virtual textures. However, using electrovibration, we cannot render surface topography. Instead, we generate high and low friction zones to render realistic textures. Earlier studies showed that there are three main dimensions of texture perception. These are hardness, roughness, and warmness. In this study, we focus on roughness perception, which is arguably the most important one. Earlier studies also show there are factors affecting the roughness perception. In our study, we focus on roughness perception of macro textures and investigate the effect of groove width and normal force on perceived roughness of real and virtual textures. To do that, we first manufactured real gratings from plexiglass. Then, to render virtual textures, we modulated the pulse train signal with a carrier signal. Next, we conducted psychophysical experiments to investigate the effects of spatial period and normal force on the perceived roughness of real and virtual textures. For real and virtual textures, we use similar setups with slight differences. You can find more information about the signal generation method and the experimental setup and procedure in our study. Results of the first experiment showed that perceived roughness of real textures increased with increasing spatial period. On the other hand, perceived roughness of virtual textures decreased with increasing spatial period. We also see average tangential force and rate of change in tangential force follow trends similar to the perceived roughness for both. Results of the second experiment showed that with increasing normal force, perceived roughness increased for real gratings and decreased for virtual gratings. Rate of change in tangential force also followed similar trends. However, average tangential force increased with increasing normal force for both real and virtual gratings. In our study, we conclude that roughness perception of virtual gratings deviate from that of the real gratings, and this difference can be explained by the degree of finger pad penetration. We also make an interesting link between our results and literature on roughness perception of virtual gratings. I recommend you to read the discussion section of our study to learn more about this link. Finally, we conclude that rate of change in tangential force better correlated with perceived roughness than the tangential force magnitudes. Thank you for listening.